So in this video, we are going to see inverse Laplace transform using convolution theorem. So first, let us see what is the definition for convolution function. So here we are considering two functions, f of t and g of t. Then the convolution of two function is defined as f of t star g of t, which is equal to integral 0 to t f of u into g of t minus u du. Here, this star represents the convolution operator. Next, coming to convolution theorem, if f of t and g of t are two functions, then the Laplace transform of convolution of two functions is the product of their Laplace transforms. So here if you see the notation explains the meaning of the theorem, that is L of convolution of two function, that is Laplace transform of convolution of two function. Here we are taking f of t and g of t. So L of f of t star g of t is equal to L of f of t into L of g of t. This is ordinary product and this is a convolution operator. So here if you see the statement, the Laplace transform of convolution of two functions is the product of their Laplace transform. So here this is what here we have written. So L of f of t star g of t is Laplace transform of convolution of two function is equal to product of their transform. So here L of f of t can also be denoted as f of s. Similarly, L of g of t can also be denoted as capital G of s. Here, this is the statement we are defining in terms of Laplace transform. Same definition we can convert it into inverse Laplace transform by taking L inverse on both sides. By taking L inverse on both sides, here right side becomes L inverse of f of s into g of s, which we have written here, which is equal to, here it becomes f of t star g of t. Now we are going to use to solve the problem for inverse Laplace transform using convolution theorem. Means this is the notation we have to use. Okay, the problem will be given in terms of L inverse of product of two terms. So we have to identify what is f of s and what is g of s. Then we have to apply this statement, right? So now we shall move on to the question. So first problem is find L inverse of 1 by s plus 1 into s square plus 1 using convolution theorem. So specifically if they ask you to find L inverse for certain function using convolution theorem, means definitely we have to use only convolution theorem. So here let us solve this question. Let us consider the question as L inverse of 1 by s plus 1 into s square plus 1. So now you can compare with this given statement. So L inverse of f of s into g of s means first we have to write it as L inverse of s plus 1, let it be one term. The next term be 1 by s square plus 1. So we can write it as product of two terms or two function. So now this becomes f of s and this becomes g of s. So here we have to apply the statement of convolution theorem, which is equal to f of t star g of t. So what do you mean by f of t? F of t is nothing but here L inverse of f of s star g of t is nothing but L inverse of g of s. So here if we want, we can include one more step by writing like this, star L inverse of 1 by s square plus 1. So now it is easy to identify what is f of t and g of t. So now by using usual formula, this can be written as e to the power minus t. Similarly, this is nothing but the formula for what? Sin t, right? So this is the term f of t as well as g of t here. So now what we are going to do here is, for our convenient, let us take it as sin t star e power minus t. So now we have to apply the definition of Laplace transform. What is the definition of Laplace transform? F of t star g of t. So if we look at the definition of convolution function, f of t star g of t is equal to integral 0 to t f of u into g of t minus u du. So that here we can apply the same definition of convolution of two function, which we can write it as integral 0 to t f of u. F of u is here sin u into g of t minus u. So here we can write it as t minus u du. So this is equal to integral 0 to t sin u, and this can be splitted as e to the power minus t into e to the power minus into minus plus u into du. So here, since we are integrating it with respect to the variable u, so t is considered as constant, so we can take this e to the power minus t as outside the integral. So now if you take this term, it becomes integral 0 to t, let it be e to the power u sin u du. So now we have to remember one formula. What is the formula? Is integral e to the power ax sin bx dx. So this is the formula we are going to use here. So what is the formula here is e to the power ax by a square plus b square into a sin bx minus b cos bx. Now we are going to use this formula to integrate this. So now this is equal to, already e to the power minus t is here. Now while applying this formula, we can have e to the power u, and then here in this integration term, a takes the value 1 as well as b takes the value 1. So here it should be 1 square plus 1 square, we can write it as 2 into a sin bx. A sin bx means here a is 1, b is 1. So it should be sin u because it is a derivative in terms of u. Minus again b is 1 here, cos u. Close the bracket. And here the limit is 0 to t. Right? So now apply the limit carefully. So here e to the power minus t is a common term. Only the term inside the bracket, the limit should be substituted. So first let us apply the first limit, upper limit e to the power t by 2 into sin t minus cos t. Minus, now apply the lower limit 0. So lower limit 0 means e to the power 0 is 1, or if you want I can write it as e power 0 by 2 into sin 0 minus cos 0. That's it. So this is upper limit and lower limit. So this is equal to e to the power minus t. Here e to the power t divided by 2 into sin t minus cos t minus this is 1 by 2. Sin 0 0, cos 0 is 1. So already minus into minus plus, so let it be plus 1 by 2. So this is the answer. Suppose if you want, we can simplify this further. So 1 by 2 we can make it as a common term. Open bracket. Now we can multiply this e power minus t inside this term. So e power minus t and e power plus t get cancelled. So we'll be getting sin t minus cos t, and this e power minus t into this will give you plus e to the power minus t. So this is the final answer. So now let us see the next question. Find L inverse of S by S square plus A square the whole square using convolution theorem. So first let us split the function as product of two terms, that is L inverse of S by S square plus A square the whole square, sorry, not whole square, S by S square plus A square, another term is 1 by S square plus A square. So now this is considered as f of s and this is considered as g of s, which is equal to L inverse of s by s square plus a square star L inverse of 1 by s square plus a square. So now applying the definition of Laplace transform, here we can use the formula s by s square plus a square can be written as cos at star. Here we should have a here, then we can write it as sin at, so that we can multiply and divide by a here. So we can write 1 by a into sin at. Now we can apply convolution definition for these two terms. So this is equal to here uh, integral 0 to t cos au into 1 by a into sin a of t minus u du. So here 1 by a is a constant term. We can take outside the integral and we can write integral 0 to t cos au into sin. Here we can write it as at minus au into du. So now we have to integrate this term, but here we are having product of two trigonometric function, so that we have to use the formula cos A sin B formula. So here let us remember the formula cos A sin B. So what is the formula for cos A sin B is 1 by 2 into sine of A plus B minus sine of A minus B. So now this is treated as A and this is treated as B. So that here this is the formula. So now this is equal to 1 by A integral 0 to t, and here we are having 1 by 2 here, so make it as 1 by 2a. Now sine of a plus b. Sine of a plus b is au plus at minus au. So au minus au get cancelled, so we can write it as sine at minus sine of a minus b. A minus b is au minus at plus au, right? So which becomes 2 times of au minus at into du. So now we have to integrate it with respect to u. So 1 by 2a is common. So integral 0 to t sin at into du minus, we can split it as two integrals. One by 2 is common to both the terms. Now 1 by 2a is common. So here in this integration, sin at is considered as constant because here the derivative is with respect to u. So we can write it as sin at integral 0 to t du minus integral 0 to t sin of 2au minus at into du. Now integrating the first term, we get u because integration of du is u over the limit 0 to t minus integration of sin is minus cos. So minus into minus we can make it as plus cos 2au minus at divided by 2a, because here 2a is the coefficient of u because the derivative is u here. over the limit 0 to t. So this is equal to 1 by 2a into sine at into u, where upper limit is t, lower limit is 0. So upper limit minus lower limit is t minus 0 is t. So we can write it as into t. Plus, here while putting upper limit t here, 2at minus at will give you cos at divided by 2a minus lower limit 0 will give you here 0 minus 80 is minus 80, but cos of minus theta is plus theta we know. So that cos of minus 80 we can write it as cos 80 divided by 2a. So this is the upper limit and this is the lower limit. Both are of same term with opposite sign. We can cancel it. And so finally we can conclude the answer as 1 by 2a into t into sine 80. So this is the way we have to use convolution theorem and convolution functions for solving inverse Laplace transform.